Some of you may have seen this model before. This is a made-up linkage model. As Ben mentioned, Mechanical Modeler is designed to accommodate linkage systems that can have multiple solutions and go through multiple motion positions. I started out very, very basic. So if you look at this model, you can see there's no mesh turned on, except there's a little bit of mesh here, here, right here, and over here. If I hit deviate, you can see, okay, a tolerance on that surface and on that surface. That's the only thing that's in this model at the moment. If I try to build it, nothing happens. There's no moves in the model. I'm starting from the basics because I want to show you that, this CAD system, if I unhide my CATIA constraints, you can see that inside the CAD system, you can define how these parts locate to each other. Okay, and inside the CAD system, you can define your GD&T. Since this information exists inside our mechanical, I can hit this button here, update moves and constraints. And you can see I can pull in constraints or joints or both. And so when I pick up the top product, it's going to look through the CAD system and pull in any constraints or joints if they exist.
Can you scroll down just to show the DCS tree is empty?
Yes.
Sorry.
And I want to show you that these are constraints inside CATIA, and then inside here, there's joints inside CATIA, which that is going to coincide with, in our software, you can see we have joints and constraints here, which I will get back to. But as Brenda mentioned, and by the way, she's here to keep me on the straight and narrow and correct me when I say things that are wrong, which can happen frequently. But you can see in the DCS storage tree, I don't have any moves. And that's kind of why when I had nominal build, you didn't see anything happen. So now I'm going to double back and I'm going to hit this update move constraints and joints again. I'm going to pick the top level assembly. And you can see that it pulled in 8 joints and 3 constraints. If I scroll down, we can minimize this CATIA stuff now. You can see that I have, we've pulled in the CATIA joints and constraints, and now you can see how this, you have a lot more mesh, because these are the features that were used in the CAD system to define the joints and constraints. At this point, I can actually do a nominal build, and now it assembles. And I can, if I hit deviate, it's actually running through its range of motion. So, joints and constraints are slightly different than our traditional moves. They're sticky, and they basically lock out degrees of freedom. So if you look at this move list over here, and I click on this Revolute joint that got imported, you can see it's highlighting an axis to an axis and a surface to a surface. Okay, so that by definition would automatically be over constrained, because an axis controls 4 degrees of freedom and a surface to surface would control 3 degrees of freedom, and the part would be over constrained. In the CAD system, that will work because they deal with perfect parts. In the variation world, we have to drop degrees of freedom based on the sequencing of how we're putting these parts together. Because of that, we have inside our mechanical modeler, we have a degree of freedom counter. So if I animate this so that you can see the build sequence, notice how as I animated it, it re-rotated this piece to assemble this. So unlike our traditional moves where we do one move at a time, when we have mechanical moves, it's going to adjust the parts to try to assemble the products. So if I animate through this one more time, okay, now if I want to put this piece into this hole, this axis into this hole, I can rotate this piece, I can rotate this piece, I can rotate this rod in order to find the solution. And so you can see how it just rotated. This is, now as I'm assembling this, it was a planer to planer, attaching it here. Now puts it on the surface. Puts this rod in here. And you can see how it adjusted this piece and this piece to assemble it. So that's why with mechanical moves, we say that they're sticky because they want to stay attached, where our conventional moves, the last move wins and it can break this connection. Because they're sticky, then this motion move allows us to put it through its range of motion, and that's why you can see this thing running through its range of motion.